Now let us find out how we can create a binary tree using pre-order and in-order combination. Let us assume that the pre-order combination given to us is this, and the in-order traversal of the same binary tree given to us is this. Now, as we had already discussed during pre-order traversal, is that the first node that you visit during your pre-order traversal is always the root node of your binary tree. So thus, when this pre-order traversal has been given to you, this first node that appears in the pre-order traversal is nothing but it is the root node of your binary tree. So we get the root node of the binary tree as 1. Now, once you have got the root node, you need to search out this node in your in-order traversal. In your in-order traversal, this node appears over here. Now, what is in-order traversal? As we had already discussed, in-order traversal means L, V, R. That means first the left subtree will be visited, then the node itself will be visited, and then we will go to the right side of the node. So everything that appears on the left hand side of this node would belong to the left child or left subtree of the node, and everything that appears on the right hand side of the node will belong to the right child or the right subtree of the node. So when we find 1 over here, everything that appears on the left hand side of 1 would belong to the left subtree of 1, and everything that appears on the right hand side would belong to the right subtree of 1. So therefore we can say that the left subtree of 1 would include 8, 4, 2, 5, and the right subtree of 1 would include 7, 9, 6, 3. Right? Now, according to definition of binary tree, the left and the right subtree of a binary tree are again binary tree. So therefore, this 8, 4, 2, 5 that we have got from the in-order traversal of the binary tree is the in-order traversal of the left subtree of the binary tree. 7, 9, 6, 3 is the in-order traversal of the right subtree of the binary tree with the node 1. Now, once you have got 8, 4, 2, 5, from the in-order traversal, you need to find out these combinations of the node from the pre-order traversal given to you. Again, once you have got the nodes of the left subtree of a node, you need to find out these combinations from the pre-order traversal. Now mind you, in the pre-order traversal, the nodes may not appear in the same sequence, but they would be lying side by side. Let us see 8, 4, 2 and 5. When you look at your pre-order traversal, you will see that you have 8, 4, 2 and 5 in the pre-order traversal as well, lying side by side but not in the same order. But that is okay. But you will find them side by side, consecutive to each other, may not be in the same order, but you will find them lying side by side. So 8, 4, 2, 5, that is the in-order traversal, and the pre-order traversal of these four nodes, the pre-order traversal of these four nodes are in the sequence 2, 4, 8 and 5. Similarly, when you come to 7, 9, 6, 3, you ought to find out these four nodes in the pre-order traversal of the binary tree. Again, they may not appear in the same order, but they would be lying side by side. So you see over here we find 3, 6, 7, 9, the same four nodes lying side by side. The orders have changed, but all four of the nodes are there. So 3, 6, 7, 9, these four combinations are, these four nodes are the pre-order combination of the right subtree of the node. Now, once you have got the traversals of the left and the right child, now we are going to continue in the same process. First, you would look at the pre-order traversal of the left subtree. When you look at the pre-order traversal of the left subtree, the first node in the pre-order traversal of the left subtree is the root node of the left child. 2 that appears as the first node of the left subtree, pre-order traversal of the left subtree, is the root node of the left child. So 2 is the root node of the left child. Now you search out 2 in the in-order traversal of the left subtree. 2 appears over here. Again, in-order traversal means L, V, R. Anything that lies on the left of the node belongs to the left subtree. Anything that lies on the right hand side of the node belongs to the right subtree. So therefore, if 2 appears over here, that means 5 belongs to the right subtree, 8, 4 belongs to the left subtree of 2. Again, 8, 4 and 5, this we have obtained from the in-order traversal. So these are the in-order traversals of the left and the right subtrees of 2. Once you have got 8, 4, you need to find out this combination from the pre-order traversal of the left child. Now you see, we get 8, 4 over here. Both of the nodes appear side by side, but the order has changed. Again, it is fine. The order might change, but they will be lying side by side, as I have already told you. So the pre-order traversal of these two nodes is 4, 8. And over here you have got 5. So the 5 remains as it is. Right? So since 5 is the only node on the right hand side of 2, that means on the right hand side of 2 you have got the node 5. Coming to the left hand side, the pre-order traversal of the left hand side starts with 4. That means the root node of this left child of 2 is nothing but 4. The root node of the left child of 2 is nothing but 4. Once you have got the root node, you have to search out that root node in the in-order traversal. Now, when you get 4 in the in-order traversal, anything that lies on the left hand side of in-order traversal belongs to the left child of 4. So 8 belongs to the left child of 4. Right? Now, so you see all this left side of 1 is done because we have come to a point where there is only one node on the left hand side. So the left side of 1 has been done with. Now we come to the right hand side. Again we follow the same process. We come to the pre-order traversal. The first node in the pre-order traversal is 3. That means the right child of 1 has 3 as its root node. Now you search out 3 in the in-order traversal. When you get 3 in the in-order traversal, you see there is nothing on the right hand side of 3. On the left hand side of 3 you have 7, 9 and 6. That means the right hand side of 3 is null, and the left hand side of 3 it has got 7, 9 and 6, which is the in-order traversal of these 3 nodes. We have to find out these 3 nodes in the pre-order traversal. They might be in different sequence, but they would be lying side by side. You see, we get the 3 nodes over here, 6, 7 and lying side by side, but their sequence has changed. So 6, 7, 9, that is the pre-order traversal of these 3 nodes. Again, from the pre-order traversal of these 3 nodes, we get 6. So 6 becomes the root node of the left child of 3. We search out 6 in the in-order traversal. We find that the right side of 6 is totally empty. That means right side of 6 is null. 7 and 9 both lies on the left hand side of 6. 7, 9, that is the in-order traversal of 6. Now when we find out 7 and 9, from the pre-order traversal, we find that 7 and 9 lying side by side over here. So that means pre-order traversal of 7 and 9 also is 7, 9. Now from the pre-order traversal, we find that 7 is the root node. 7 is the root node. And from the in-order traversal, we find that 9 lies on the right hand side of 7. So 9 lies on the right hand side of 7. Right? So we come to a point where we have come to only a single node. That means our recreation of the binary tree is done. Now I would write down the binary tree as a whole for you. The binary tree as a whole for you is 1, left hand side 2, right hand side 3, left child of 2 is 4, left child of 4 is 8, right child of 2 is 5, right child of 3 is null, left child of 3 is 6, left child of 6 is 7, right child of 7 is 9. So this is the same tree that we had solved the last day for pre-order and in-order traversal. So this same tree we have recreated back given the pre-order and the in-order traversal of the tree.